Llullaillaco. Llullaillaco, Spanish pronunciation, is a dormant stratovolcano at the border of Argentina, Salta Province, and Chile, Antofagasta Region. It lies in the Puna de Atacama, a region of tall volcanic peaks on a high plateau close to the Atacama Desert, one of the driest places in the world. It is the second highest active volcano in the world after Ojos del Salado. Llullaillaco formed during two different phases in the Pleistocene-Holocene out of dacitic lava flows. The oldest rocks are about 1.5 million years old. About 150,000 years ago, the volcano's southeastern flank collapsed, generating a debris avalanche that reached as far as 25 kilometers, 16 miles, from the summit. The youngest dated rocks were erupted 5,600 plus or minus 250 years ago in the summit region, but there are reports of activity from the 19th century. The mountain's first recorded climb was in 1950, but traces of earlier climbs and a number of archaeological sites were found on the mountain and at its feet. Llullaillaco marks the highest archaeological site in the world. In 1999, the mummified remains of 3 children, known as the Children of Llullaillaco, were found at its summit. They are presumed to have been human sacrifices. The occurrence of mice in the summit region has been reported as well. Name. The name Llullaillaco is derived from the Quechua word Lola meaning false, liar deceitful and Yaku or Laco meaning water. This name probably refers to the meltwater from snow, which flows down the slopes but then is absorbed into the soil. Normally such mountains are sources for water. It is possible that it instead refers to the precipitation regime, which starting from Llullaillaco becomes dominated by winter precipitation. Another translation in Aymara is hot water. Geography and geology. Volcanism in the Andes is caused by the subduction of the Nazca Plate and the Antarctic Plate beneath the South America Plate. The Nazca Plate subducts at a speed of 7 to 9 centimeters per year, 2.8 to 3.5 in/year, and the Antarctic Plate at a speed of 2 centimeters per year, 0.79 in/year. Volcanism does not occur along a continuous chain. There are 4 separate regions named: the Northern Volcanic Zone, the Central Volcanic Zone, the Southern Volcanic Zone, and the Austral Volcanic Zone. The formation of magma results from the release of water and other volatile material from the subducting plate, which is then injected into the above-lying mantle wedge. The volcanic zones are separated by areas where the subducting plate subducts at a flatter angle and volcanism is absent. The Peruvian flat slab between the northern and the central volcanic zones is associated with the subduction of the Nazca Ridge. The Pampean flat slab between the central and the southern volcanic zone is associated with the subduction of the Juan Fernandez Ridge, and the Patagonian volcanic gap between the southern and the austral volcanic zone is associated with the Chile Triple Junction. About 178 volcanoes are found in the Andes, 60 of which have been active in historical times. In addition, large calderas and monogenetic volcanoes exist in the Andes. Local setting. Llullaillaco is part of the Central Volcanic Zone. At least 44 volcanic centers with historical activity and 18 large caldera-forming volcanoes have been identified in the Central Volcanic Zone. Volcanism in the Central Volcanic Zone mostly occurs on the Altiplano and the Cordillera Occidental. A number of volcanoes that reach heights of over 6,000 meters, 20,000 feet, above sea level. Large Miocene ignimbrites that cover large surfaces are also part of the regional geology. Llullaillaco is located about 300 kilometers, 190 miles, east of the Peru-Chile Trench. The Huaorani-Benioff zone is 180 kilometers, 110 miles, deep. Llullaillaco is located in the northwestern Argentine Andes, towards the southern end of the Puna. The border between Argentina, Salta Province, and Chile crosses the volcano. It lies in the Puna de Atacama, a region of very high volcanic peaks on a high plateau close to the Atacama Desert, one of the driest places in the world. The volcano is an imposing mountain, rising by 3,800 meters, 12,500 feet, above the Salar de Punta Negra 36 kilometers, 22 miles, away. With a summit height of 6,723 meters, 22,057 feet, or alternatively 6,739 meters, 22,110 feet, or 6,752 meters, 22,152 feet. It is the second highest active volcano in the world after Ojos del Salado, 6,887 meters, 22,595 feet, 27 degrees 07 S 68 degrees 33 W. The height of the mountain and the clear air in the region make the Llullaillaco visible from Cerro Paranal, 189 kilometers away as measured by Google Maps. The region is dry and located at high altitudes, making work in the area difficult. 17 kilometers, 11 miles, farther east of Llullaillaco lies the Miocene Cerro Rosado volcano, 5,383 meters, 17,661 feet. This volcano has erupted dacitic lava flows during the Pliocene Quaternary on its northeastern and southern flanks. 20 kilometers, 12 miles, east of Llullaillaco, and behind Cerro Rosado, lies the Salar de Llullaillaco, 3,750 meters, 12,300 feet, a salt pan with warm springs at its western and southwestern shores. There are 3 abandoned borate mines, Mina Amalia, and the salt mines Mina Luisa and Mina Maria, and the recent lithium prospect Proyecto Mariana at Salar de Llullaillaco. Mitral Mountain, 5,015 meters, 16,453 feet, lies southwest of Llullaillaco and is of Miocene age. It features an eroded crater that opens to the northwest. Iris Mountain, 5,461 meters, 17,917 feet, north of Llullaillaco is constructed of Pliocene rocks. Other volcanoes in the neighborhood are Dos Naciones, Cerro Sheila, and Cerro 5074. Llullaillaco is associated with a local crustal upwarp, the volcano. Llullaillaco is a stratovolcano which rises 2,200 meters, 7,200 feet, above the surrounding terrain. The edifice has an elliptical shape with dimensions of 23 by 17 kilometers, 14 miles times 11 miles, and has a volume of about 50 cubic kilometers, 12 cubic miles minus 37 cubic kilometers, 8.9 cubic miles. It is formed by thick dacitic lava flows erupted during the Quaternary. These flows extend away from the volcano and form its summit. An older unit is formed by ignimbrites and pyroclastic flows. Older lava flows extend west from the volcano and are partly buried by sediments closer to the edifice. These flows reach lengths of 20 kilometers, 12 miles, and form about 70% of the surface of the volcano. The slopes of the volcano are fairly steep, with an altitude drop of 1,800 meters, 5,900 feet, over only 3 kilometers, 1.9 miles, horizontal distance. The slopes high up are steeper than those at lower altitudes. A crater at 6,100 meters, 20,000 feet, altitude was formed early in the development of the Llullaillaco volcano. Erosion has reduced it to a plateau. This crater is filled with snow and ice. The ice shows evidence of recent geothermal heating. The summit of Llullaillaco is formed by a small cone with about 4 associated lava domes, which reach lengths of 1 to 3 kilometers, 0.62 to 1.86 miles, and have abrupt walls. Large dacitic colae emanate from the summit of the volcano and are young in appearance. One extends north of the volcano and the other one south. Their overall length is 4.5 to 8 kilometers, 2.8 to 5.0 miles, and their flow fronts are up to 15 meters, 49 feet, thick. Morphologically, these flows are reddish-black lava flows and feature blocks with sizes of 5 meters, 16 feet. The southern lava flow was 6 kilometers, 3.7 miles, long and was fairly viscous when it was erupted. It almost reaches a road southwest of the volcano. These flows feature levees and ridges. At first they were considered to be Holocene, but argon dating indicates they are of late Pleistocene age. Some traces of glacier activity are found in the summit area. At least 2 stages of construction are recognized, the Llullaillaco I and the Llullaillaco II. The first stage originated from 2 centers and is now extensively degraded by glaciation and hydrothermal alteration. This applies especially to the 5,561 meters, 18,245 feet, high Azafrera Esperanto Mountain 5 kilometers, 3.1 miles, north of the Llullaillaco, where little original volcanic substance is preserved and where erosion has exposed deeply altered white rock. Llullaillaco II on the southern and northeastern flank is better preserved. The toes of the lava flows reach thicknesses of 500 meters, 1,600 feet. Its lava flows are less extensive than the ones of the Llullaillaco I. Pyroclastic flow deposits with a composition similar to Llullaillaco II are found on the southern slope of the volcano and may have formed before the lava eruptions began. Volcanism in the central volcanic zone may be affected by deep-seated lineaments, which control where volcanoes and geothermal systems form. Such lineaments extend diagonally across the volcanic arc and are accompanied by volcanic manifestations at substantial distances from the arc. One of these lineaments, the Archibarca, runs beneath the Llullaillaco and is also associated with the Escondida copper deposit, Corrida de Cori, Archibarca, Antofagasta, and the Galán caldera. Other lineaments include the Calama El Toro. Several dry valleys originate on the Llullaillaco, including Quebrada de las Oridas on the north-northeastern slope, Quebrada El Salado and Quebrada El Llullaillaco on the northwestern slope, and Quebrada La Barda on the southwestern slope. The Quebrada El Llullaillaco drains into the Salar de Punta Negra northwest of the volcano. The volcano is relatively unaffected by water erosion. Water is only episodically present on the mountain. In addition, there is a lake called the Llullaillaco Volcano Lake on the mountain. It is one of the highest lakes in the world. Periglacial phenomena are observed on the Llullaillaco, commencing at 4,300 meters, 14,100 feet, altitude and reaching their maximum around 5,100 to 5,400 meters, 16,700 to 17,700 feet, on the Chilean and 5,350 to 5,700 meters, 17,550 to 18,700 feet, on the Argentine side. There, solifluction and cryoplanation surfaces are developed, including lobe-shaped ground and block ramparts. These landforms have been mapped on the northwestern side of the volcano. Patterned ground is also common. Permafrost is found at higher altitudes. Cryoplanation and solifluction landforms are also observed on Iris and Mitral. Other than on periglacially influenced terrain, the ground at Llullaillaco is formed mostly by lavic rocks and block debris, which are frequently buried by tephra. Two abandoned sulfur mines can be found north and south of the Llullaillaco. The northern mine is known as Azufrera Esperanto and associated with an area of hydrothermal alteration. A path or road leads up to that mine from northwest. Debris avalanche. A major landslide occurred in the volcano's history during the late Pleistocene, probably triggered by volcanic activity. This landslide descended the eastern-southeastern flanks of the volcano into Argentina, first over a steep slope of 20 degrees on the volcano, split around Cerro Rosado and entered the Salina de Llullaillaco 25 kilometers, 16 miles, east of the summit, extending up to 5 kilometers, 3.1 miles, into the Salar. The toe of the avalanche reaches a thickness of 10 meters, 33 feet, above the Salar in the avalanche's southern lobe. Part of the avalanche was channeled in a valley between Cerro Rosado and an unnamed volcano farther south. When it reached Cerro Rosado, the avalanche climbed about 400 meters, 1,300 feet, and mostly continued to flow southeast into the main avalanche path, with only a small flow continuing northeastwards. Part of the run-up avalanche later collapsed backwards over the main avalanche deposit. Unlike Socampo farther north, a landslide scar is only poorly developed at Llullaillaco despite the large size of the collapse. It was largely filled in later by lava flows and volcaniclastic debris. This landslide has been subdivided into 4 facies and features landforms like levees up to 50 meters, 160 feet, high, longitudinal ridges and a run-up mark on Cerro Rosado. Such ridges may be associated with uneven underlying terrain. The surface of the slide is covered by lava bombs less than 1 meter, 3 feet 3 in, long, blocks exceeding 2 meters, 6 feet 7 in, width, cobbles, and gravel-like rocks. Close to the collapsed scarp on the Llullaillaco, the largest blocks with sizes of up to 20 meters, 66 feet, are found. Overall, the margins of the landslide are very crisp and the surface covered by hummocks. The landslide deposit covers a surface of about 165 square kilometers, 64 square miles. Its volume has been estimated at 1 to 2 cubic kilometers, 0.24 to 0.48 cubic miles, and the speed at 45 to 90 meters per second, 150 to 300 feet per second. This speed range is comparable to that of the Colima, Lastaria, and Mount St. Helens debris avalanches. The landslide occurred no later than 156,000 to 148,000 plus or minus 5,000 years ago. It might coincide with the 48,000-year-old lava flow. Some volcanic rocks were still hot at the time of the collapse, indicating that volcanic activity occurred immediately before the collapse. A smaller undated avalanche occurred on the northeastern flank. Such landslides are common at volcanoes, where they are favored by the steep edifices that form from lava flows being stacked on top of each other. It is not usually known what triggers the collapse, although eruption-associated earthquakes are suspected to play a role. Other volcanoes in the region with sector collapses are Las Taria, Lage, San Pedro, Socampa, and Tata Sabaya. The Mellado and Cerro Rosado volcanoes close to Llullaillaco also display evidence of sector collapses. Basement. The terrain around Llullaillaco consists of andesite and dacite lavas and pyroclastics of Miocene to Pliocene age. Some Oligocene-Miocene layers are exposed in the Quebrada de las Orillas. Dates obtained by Argon dating range between 11.94 plus or minus 0.13 and 5.48 plus or minus 0.07 million years ago. 15 kilometers, 9.3 miles, west of Llullaillaco due Paleozoic granites and volcanic rocks crop out. Elsewhere these layers are buried by Cenozoic rocks. There are several faults in the region, such as the Imalaxolina del Fraile lineament whose movement has influenced the activity of Llullaillaco. Composition. Llullaillaco has mostly erupted dacites with medium potassium content, with rocks becoming more felsic the younger they are. Rock samples taken from Llullaillaco are mostly porphyritic or vitrophyric, with a glassy or microcrystalline matrix. Phenocrysts are mostly plagioclase, with mafic phenocrysts being dominated by orthopyroxene and smaller amounts of biotite, clinopyroxene, and hornblende. Ilmenite, magnetite, and sulfide minerals are also present, magnetite especially in the more oxidized older lavas. Some phenocrysts show evidence of a complex history. Quartz is rare. Older lavas have developed a red color and contain oxidized iron in form of hematite. Lavas from Llullaillaco are gray. The content of CO2 is 65 to 67%. The rocks belong to the calc-alkaline series. Trace element data are typical for central volcanic zone rocks. High potassium content is typical for Shoshonite-like lavas erupted at large distance from the trenches. The composition may reflect magma differentiation and a solitary magma chamber, but with occasional replenishment with more primitive magma. Magma mixing and plagioclase crystallization occurred in it. A lithospheric structure probably directed magma flows over long time periods along the same pathway. The depth of the magma source probably varied over the history of the volcano. The total magma output at Llullaillaco is about 0.05 cubic kilometers per millennium, 0.012 cubic miles / ca minus 0.02 to 0.04 cubic kilometers per millennium, 0.0048 to 0.0096 cubic miles / ca. Geological history. Research by J.P. Richards and M. Villeneuve has allowed the determination of the geological history of the region. Had volcanism during the Eocene and Oligocene been centered on the Precordillera, increased subduction of the Nazca Plate during the late Oligocene caused the volcanic arc to broaden to about 250 kilometers, 160 miles. 25 million years ago, the Quechua event triggered the uplift of the Puna Altiplano, a highland covering a surface area of 500,000 square kilometers, 190,000 square miles, and reaching an altitude of 3,700 meters, 12,100 feet. In the late Miocene-Pliocene a phase of strong ignimbrite volcanism occurred. About 2 million years ago, the Diaguita Deformation was characterized by a change in the deformation regimen from crustal shortening to strike-slip faulting and of volcanism from voluminous felsic eruptions to isolated stratovolcanoes and back arc mafic volcanism. A slowdown in the subduction may have caused this change. Nowadays most volcanism occurs at the western edge of the Puna, where volcanoes such as Lascar and Llullaillaco formed. Climate, glaciers and biota. The climate at Llullaillaco is cold and dry. The average temperature is about -13 degrees Celsius, 9 degrees Fahrenheit, with temperature maximums ranging -8, -13 degrees Celsius, 18 to 9 degrees Fahrenheit, between summer and winter. Ground temperatures however can reach 12.5 degrees Celsius, 54.5 degrees Fahrenheit, during the day in summer. The temperature of the ground fluctuates strongly during the day. The climate is extremely sunny on account of the lack of a cloud cover, the high altitude, and the close coincidence between summer solstice with the day where Earth is closest to the sun. Snowfall can occur down to altitudes of 4,000 meters, 13,123 feet. Precipitation is episodic to the point that it is difficult to give average values. It is most often associated with either convective or cyclonic activity during summer and winter respectively. Small glaciers are found above 6,000 meters, 19,685 feet, altitude. Other sources contend there are no glaciers on the Llullaillaco, which would make it the highest mountain in the world without one, although the existence of an ice slab on the western slope was reported in 1958. However, the Llullaillaco has snowfields. 1 to 1.5 meters, 3 feet 3 and 4 feet 11 in, high penitentes occur above 5,000 meters, 16,404 feet, altitude, especially in more sheltered areas. 1 meter, 3 feet 3 in, high penitentes were observed in 1954. Snow covers the terrain above 5,400 to 5,800 meters, 17,700 to 19,000 feet, altitude. Gullies that are found in the area probably result from meltwater runoff. The snowfields on the Llullaillaco supply water to the Salar de Punta Negra. The existence of a cirque on the northwestern slope has been postulated. It was once believed that Llullaillaco had experienced 3 large glaciations, but the moraines are actually mudflow deposits. However, during the Pleistocene glaciers reached down to 5,100 meters, 16,700 feet, altitude on the northwestern slope. Lava flows have overrun some of the glaciated surfaces, and it is possible that lava flows induce the melting of glaciers. A number of glacial landforms elsewhere were destroyed by mudflows during the time of Llullaillaco's last activity. Llullaillaco may not have been glaciated at all during the Pleistocene. Between 24 and 25 degrees southern latitude, the Andean dry diagonal crosses the Andes. At this latitude, half of the precipitation falls in summer and the other half in winter. The formation of this dry diagonal is an effect both of the rain-shadow effect of the Andes, air subsidence within South Pacific High, and the cold Humboldt current off the Pacific coast. This is the reason why the Atacama Desert exists. The extremely arid climate at Llullaillaco is also a consequence of these climatic effects. Vegetation is scarce in the arid climate. Vegetation at Llullaillaco begins at 3,700 to 3,800 meters, 12,100 to 12,500 feet, altitude with Acantholippia punensis, Atriplex imbricata, and Cristeria anicola. They are joined at 3,900 meters, 12,800 feet, altitude by Stepa Phrygia, which can be found up to 4,910 meters, 16,110 feet, of altitude. The maximum vegetation density is found around 4,250 meters, 13,940 feet, with 12% of the surface, and decreases thereafter, probably due to the low temperatures. At this altitude, Adesmia spinosissima, Fabiana bryoides, Molinum crassifolium, and Parastrophaea quadrangularis are found in addition to the previously mentioned plants. Above 5,000 meters, 16,000 feet, elevation there is no vegetation. Mice were filmed at 6,205 meters, 20,358 feet, in 2013, and an expedition in February 2020 found mice all the way to the summit, where a mouse of the species Philatus anthopegus was captured. This is the highest altitude in the world at which a mammal has been found to live. Weakly developed fungal and bacterial communities have been found in the soils at Llullaillaco, with better developed algal and cyanobacterial communities found on the penitentes. Some soil microbes may depend on volcanic carbon monoxide. The environmental conditions in these soils are among the most extreme on the planet, with aridity, strong UV radiation, daily freeze-thaw cycles, and a lack of nutrients. Organic material transported on the mountain by winds may be the principal source of food for some of these microorganisms. Dry valleys and sheltered areas feature grasses. A permanent spring is found in Quebrada de las Soritas. Deposits in this valley indicate that between 2,436.8 plus or minus 49 and 1,593.1 plus or minus 36 radiocarbon years ago runoff was more intense.